Whoever friends they are not aware that we are here, please do let them know that we are starting. Okay, so last week lecture I already go through the first part or most of the part of the software testing concept, and I have stopped until the principles, correct? The 7 principles I have covered, and my group, I think we have even discussed the tutorial. Okay, how was your classes on Saturday with the what's her name? Sorry, I forgot. With Marina. Yeah, TS Marina. How was the class? Was okay? Good. Okay, she's our first timer, part-timer here, but she's good. She's actually teaching in UNICEF. Okay, so she's actually more into this area, and that's why. Okay, so since she's first timer, in case if she need any time or something, just communicate with her. She tried to request for changes of the classes, I believe. I'm not sure what happened. Whatever class changes or you need to bring up and down the classes, please communicate with her so that she can communicate with the faculty, because I cannot do anything much about it. Okay, Miss Yasota's class, was everything okay? Tutorial, practical. The assignment has been brief. This week too started. Okay. Okay. So anything, just do let me know so that we can handle it as soon as possible without dragging it longer. Okay. Okay, so let's continue with the balance part of chapter 1, and then I'm going to start with chapter 2. Okay, so debugging versus testing. Are they same? Of course, the slide already say that they are not. Am I right? That's why we have the word of versus there. So the thing is, most students, they got confused when it comes to debugging, because some of you from your diploma, some of you from your year 1, you have in the mind that when we say debugging, it means we are doing the testing. Is it correct? Because when you go for programming courses, when you do the code, you will run the compiler, correct? So when they do this debug, they think that it is actually testing. Actually, no. Okay, debugging and testing, they are two different things. They are totally two different things. Okay, your slide might not really explain much, but we will explain. Okay, if you see, as what we have discussed last week, testing, what is the purpose of testing? We want to identify the defect, correct? It means when we have developed the program, when we do the testing, the aim of the testing is we want to identify the defect, because why you need to identify the defect? Why don't just leave it there? Why we need to identify the defect? Why we need to identify the defect? So that we can debug. Yes, so that we can debug. Because we want to identify the defect so that we can do the debugging. So debugging here is not about identifying the defect. Testing is identifying the defect. Debugging is we want to analyze where is the root cause of the defect so that we can fix it. Remember, our aim is actually we want to identify the defect so that we can fix it when we are passing the software to the client, so that there will be no issue after that. So here, when we say testing, it means we want to identify the defect, and when we say debugging, it means we want to analyze the root cause of the defect to fix it, to repair it. Okay? Just because your compiler, you see the word debug, Okay, actually it's not about testing. It's actually you want to know where is the syntax error happened. You want to understand what is the root cause of this syntax error, and then you want to fix it. So that debug is actually not testing, but it is more to the debugging. Okay, so from what we have discussed last week, okay, there will be 3 different group of people can conduct testing. Correct? Who are the 3? Who are the 3? Who conduct software testing? Who are the 3 people or 3 roles? Huh? Sorry? User, end user, software tester, programmer, software developer. They are part of the testing. Am I right? So if you see here as a software tester, let's separate these roles. We as a software tester, and then there is group of people who is developing. Okay, so when we say testing, okay, it can be conducted by the software developer. Okay, when they do the development of the program, and when they pass it to us, then we as a software tester, we will conduct the testing too. And also same goes to the end user. But when it comes to debugging, is these 3 people are part of debugging? Is the same 3 people are part of the debugging? No. Who will be part of the debugging? The developer. So here we as a software tester and the end user, we identify the defect. We give the feedback to the programmer, to the software developer. Software developer will be the one try to analyze the root cause of the defect. Where is the problem? Where it come from? Why this happened? Because they are the one develop the code. So let them deal with it. So they will be the one do the debugging. So when we say testing, do we require programming knowledge, programming skills? Not really. But if you go with it, then it's an advantage. But when it comes to debugging, is it compulsory to have programming knowledge? Yes, because if you don't able to analyze the source code, you don't able to identify the root cause, you cannot do the debugging. Got it? Clear? So debugging and testing, they're not the same thing. So we have different aspects where we can differentiate them. Okay, the last statement say here, debugging supports testing. How is that? How this debugging can support testing? How? What is mean by debugging support testing? It's not supporting each other, is it? Debugging is not supporting testing, is it? Which one will happen first? Which one will happen first? Testing. Okay? We will do the testing. When we identify the defect, then it will move to the debugging, because we want to do the fixing on the defect which has been identified. So how this debugging supports testing? If there is no debugging, what actually happened to the testing? It's just hanging, am I right? You just identify the defect and nothing happened. The defect is still remain there. There is no fixing happen. So if you see, whatever we identify, it means whatever defect, whatever unexpected result, unexpected behavior of the system which we identify during the testing, it must be solved by doing the debugging. So when there is no debugging happen, it means whatever we open, we are not closing it. You know, whatever we started, we are not going to end it. So that's how debugging will support the testing. So what we identify, we actually need to fix it through the debugging. Okay, then after that, if we require, then we might need to do repetition of the testing, like to conduct the retest to confirm if the debugging part is functioning correctly or not. So that will be like the second round of the testing. Okay, got it? Can be clear the difference between debugging and testing? Okay. So this will be the normal test processes involved. Okay, so normally when we say we want to conduct the testing, okay, it's not like, okay, we wake up and then, okay, let's start with the testing. No. Okay, so as how we have the software development life cycle, which we need to make sure the entire life cycle is going on well, the same thing happened to software testing life cycle, because we have a life cycle, what we need to start, what we need to follow. So there is a flow to follow also. Okay, so test processes here will always start with the test planning and control. Okay, so if you see your assignment is 100% about the test plan and also test case. Anyone of you not even aware of what is the assignment about until now? It's already week 2. Okay, your assignment where you need to produce these 2 documents. These 2 documents, they are software testing documents. Okay, software engineering is full with the documentation. Okay, if you are regretting now, I think it's a bit too late. Year 2, Sem 3. Am I right? Okay. Let's go with it and complete your year 3, Sem 3. Okay, so it's full with the documentation. So every stages in the software development life cycle, you are going to prepare documentation. Okay, RSD student, I'm not well known about your documentation much, but when it comes to software development life cycle, using this software engineering, all this full with the documentation. So as part of the software testing phase, okay, you will involve with a lot of documentation. A lot. Not only these 2. I have limit to these 2. Actually, there are many documentation before the testing, while conducting the testing, after the testing. So each of these stages, they have different documentation. But the problem is we only have 14 weeks. So we cannot cover all the documentation. So the only documentation I covered here is the test plan and also the test cases. Okay, so as part of the first process, the test planning and control, it means we are going to do the planning of the testing we are going to conduct maybe after 3 months. So we need to do the planning activity here. So it means we want to know what we are going to test, how we are going to test, where we are going to test, when we are going to test, who going to test. Answering all these answers will be your test plan document. So it means the overall planning of your testing, you must document. Okay, and at the same time, we need to do some controlling, because there might be any unexpected risk to happen. If you see part of the content for your test plan, there is risk management. Do you go through the test plan table of content? There is one called risk management, which is the project risk and the product risk. So it means whatever unexpected thing can happen, which is going to disturb our testing, we must manage it, we must control it. If no, means we might not able to complete our testing. So in our test planning, we need to have the ahead planning of how we are going to manage this risk if happen. So let's assume you plan for the testing, okay, which you are going to conduct in June later, okay. Then all of a sudden they declare another round of MCO. We really wish for that, right? So that we can have online classes. I will not be stuck in the traffic. Okay, so how we are going to handle that when it comes to last minute things where people are not moving out anymore, where we might not have some face-to-face communication, we cannot have the testing in the environment at the workplace. So a lot of things we need to change now. So when we set control, it means we want to have early preparation, how we are going to control all this unexpected situation, so that it will not disturb our testing and our testing can be still going on within the schedule, within the budget, within the resources. Okay, so the first process is all about the planning and how we are documenting into our test plan, because this test plan must be presented, must be reviewed, must be approved for you to proceed with the testing. Okay, then the second one is the test analysis and the design. So here, when we say that we want to proceed with our testing, we need to clear up what exactly we want to test. So we need to do some analysis on the requirement. So if this requirement is what we are going to test, if our test plan is correct based on what the requirement said or not. So we will conduct some test analysis and design. So here we are going to do the design of our test cases for each of the test items which we are going to test later. So when we say preparing test cases, is it only testing the functionalities? Is it our testing is all about the functional requirement? No. Okay. Sometimes, no matter how well the software is handling all the functionality, but if the performance is not good, do you think your client will be happy? Like the response time is taking like hours to wait just to open a simple thing. Okay, you should have better experience, right? Whenever it comes to our student intranet, when you want to do any course registration, co-curriculum registration, and this happen like in a specific duration, very limited time is given, and the entire Thai UMT student is coming there because they want to register for the co-curriculum. What happened? What happened? Cannot even open the page, cannot even log in, cannot even do anything. So this is actually indicating the intranet did not support certain numbers or certain load of users at the same time. So it means they didn't give importance to the performance of the system. So that's why I said for your assignment, you are not going to select anything related to Thai UMT. Let's not bring them inside here. Is anyone? Is anyone under Miss Yasota or Miss Marina? Anyone propose to test Thai UMT website, Thai UMT student intranet, Thai UMT, what other system they have? Anyone? Please, no, I will check back the grouping. Okay, so please don't test their product. We don't want. Okay, so when we said we want to do the analysis, we want to do the design, we must make sure that we analyze and we design the test cases from both sides. It means the functional requirement and also the non-functional requirement. How important is the functionality? That is importance of the non-functionality too. Just because the performance is good, but the functionality is not working, that is problem. And just because the functionality is working, performance is so bad, that is another problem. So we always want to make sure that they are balanced. Okay, so when we analyze, when we design the test cases, we cover both of these areas. Okay, and then the third one is the test implementation and the execution. So now we are going to implement whatever we need to set up for the testing. For example, our test environment. So when we say test environment, it involves with all the softwares, hardwares, the test data, the network, any equipment, testing tools or debugging tools, whatever tools we need. Okay, so we need to do all this implementation according to what we have planned, what we have mentioned in the test plan. Then according to our test cases, we will do the test execution. So test execution means you have prepared the test case. Now you follow the test case, you conduct or you execute the function, and then to see what will be the result. So if our actual result is tally with the expected result, then the test execution is pass. If our actual result is not tally with the expected result, then our test execution is failed. Okay, so this fail part is what we need to deal after that. Okay, then the fourth process is evaluating the test exit criteria and report. So normally when we want to start a testing, when we are conducting a testing, when we are going to end the testing, there is some criteria which we need to evaluate. So we call it as a test entry criteria, test continuation criteria, and test exit criteria. These three. Okay, if you see for your test plan, you only have two, which is the test entry criteria and the test exit criteria. But the one in the between, I don't include it. Okay, let's see one by one. Test entry criteria means what are the criteria which we must fulfill for us to start with the testing. Just because you plan for the testing doesn't mean you can just simply start. There is some criteria which we need to identify earlier. We need to document in the test plan so that before we will start the testing in June later, we need to check back if these criteria has been fulfilled before we can start. Okay, and these criteria will be different when you are conducting a testing for a newly developed system and when you are testing a completed system, or when you are doing a testing after has been tested before. You know, we have few different situations when we will be doing the testing. For example, when we say newly developing system, okay, the criteria will be more to if the system is completed, if all the modules, the functionality has been integrated, okay, and if the program is not completed, do we need to have dummy codes? So the criteria here is more on confirming if the system is complete or not. Okay, other than that, of course, as a general, is the documentation has been prepared or not. For example, is the test plan done? Is the test case done? Okay, other than that, if the testing environment has been set up or not, and if the software testers, they are available or not. So this kind of criteria we must check. But when it comes to a well-developed software, okay, I cannot say the same criteria because it's already completely developed. So my criteria will be a bit different, where is the system stable to be testing or not? Because sometimes just because the system is working, it might not be stable yet to be tested. Are you the only software tester going to test? No, you might be a team of software testing team here. So when it comes to software testing team here, what will happen to the system when multiple testers is testing at the same time? Can it be working fine? Is it stable, or is it keep on crashing? Is it lagging? So all these need to be confirmed first before we can start the testing. Okay, so when we want to enter into the testing phase, we need to check all these test entry criteria has been fulfilled or not. So the same thing goes when it comes to test exit criteria. It means before we will exit the testing phase, it means before we say we are done with the testing, we have completed the testing, we are going to exit the testing phase. So there is some criteria which we need to check. Am I still checking something similar like test entry criteria here? Cannot, right? This criteria will be totally different, where I'm going to check, have we execute all the test cases? Is there any missing test cases? And what is the percentage of the passed test cases? What is the percentage of the failed test cases? How many of high critical defects? How many of low critical defects? So this kind of result from the testing will be the criteria which we need to check before we will exit from the testing phase. Can you understand? Test entry means before we will start the testing. Test exit means before we will end the testing. This is what you need to prepare for your assignment. But in the between, we have one called test continuation criteria. Test continuation here means, are we going to continue with the testing, or we are going to put it on hold? Not stopping, put it on hold for some time. So normally after 1 week, you have started the testing, we need to check how is the testing going on. It means how is the system support the testing, how is the percentage of the failed test case in the first 1 week. So let's assume you have started the testing. On the first week, you found 50% of the test cases is already failed. Is it a good system to continue? Because we cannot waste our time, we cannot waste our resources to continue to test when we already know the system is full with defect. 50% is very high. Normally, in our test exit criteria, we must make sure that our pass test case must be 95% and above. 95, some companies 97 and above. So what is the allowed percentage of failed test cases? 5 and below. 5 and below. So let's assume in the first week, depends on the numbers of the test case you are executing, 50% already failed. Okay, better stop. Better put it on hold. Don't waste time. Don't waste the resources. Return it back to the development team. This always happens when it's a newly developed system. So this test continuation criteria will indicate if the system need to be proceed or we need to hold it for a while. Okay? In your assignment, do you need this test continuation criteria? You have no choice. You need to complete your assignment. So you must start the testing and you must complete the testing. So there is no reason in the between for you to hold it. So that's why for your assignment, I don't include the test continuation criteria. You only have the test entry and the test exit. Got it? Clear? Okay. So this evaluating of the test exit criteria to confirm that we have done with the testing. We have achieved the test exit criteria, and we can end the testing and we do the reporting. Okay. Then the last phase will be test closure activities. So whatever we need to conduct to do the closing of the testing. For example, if we have some defects which we have identified, and then we have to report it back to the development team, and then if the development team has do the fixing, and then we want to close that, okay, all these defects has been identified, has been debugged, and everything is settled, so we do all the closuring activities so that we can close our testing. So this normally will be the processes involved when it comes to software testing life cycle. Okay, so under each of this process, different documentation will be involved. So here for your assignment, you only deal with two, which is the test plan for the test planning part, and then test case for the designing, and also for the execution, because you still need to fill up the result there on your test case. So it means you execute the test cases to get the result, either pass or fail. Okay, for your assignment, in case if fortunately you identify any defect, okay, you don't need to do defect reporting. Okay, we are not going to do the debugging. You don't need to communicate with the for example, Shopee. You want to communicate with the Shopee to say that, oh, we have identified a defect. You don't need to do all that. Okay, we will just do the documentation according to the result we have done. We end there. Got it? Clear? Okay. Another one more thing just to inform you. What system we were talking yesterday? What you are doing? Yes.
Shopee.
Okay, Shopee. What we tried yesterday? The search product, correct? Okay. So if you see, like Grab, in case if any of you using Grab application or Shopee, Lazada, okay. So if you realize when you do the search function, when you put any location name or any product name, even though you put something which is not real name, it will still try to give you the result. Okay, yesterday we have tried that. So the same thing goes to Grab application. When you give like a long distance location, it will still try to calculate for you. We have done that before. So this is actually not a defect. That is their requirement, because they don't want to give you empty result. They don't want to say that no result found, because it's giving something in a like negative view. So they always try to give you whatever related to every single thing you are typing. So don't say that you expect the application to display error message, but it's still giving you the result. And this is failed test case because it's a defect. You cannot say that. You get? Because their requirement is like that. So you cannot say that I tried to put this, what you typed yesterday, your name, is it? You type your name and then you still get a product with that name. Something like that. Shopee did that. So whatever word it's trying to find a product name, it still will display as a result. So just because you give your name, it is not a product name. You cannot say that this is a defect because I expect to see error message. No. Got it? Because their requirement is like that. So we cannot say it's a defect unless it is totally, you know that this is wrong. This is not how it's supposed should be. Then that one we can call as a defect. Okay, so that's why I said no worries if it's a defect, if it's not a defect, because we are not moving after that. We just want to do the testing to know how to prepare the test plan, how to prepare the test case, how to execute the test case to fill up the result. That's it. How the software is working is their problem. Got it? Clear? Okay. Okay, so the psychology of testing. So normally we always see how is the level of effectiveness of the testing, okay, and also the independence level to carry out the testing. So if you see here, when we said the closest person to a program is actually the developer, is actually the programmer who do the coding, who develop the program. So if you see, can a programmer test their own program? They do. Am I right? They do. When you, as a programmer, you do the coding, you will be the first one to run the code and to do the testing and then to do the fixing because you are working on it. Am I right? But is it going to be effective testing for me to say that, okay, the programmer have tested whatever they have developed. Let's deploy it to the client side. Can I? Why? Why? Why I cannot just do the white box testing at the programmer level when they are developing the program? After that, we skip the testing phase for the software tester and we deploy it straight. Why we cannot do that? Why we cannot do that? Is programmer is not a good tester? Can programmer test their own program? Do you guys have answer? I'm expecting answer here. Bias. Okay. So when I let you to test your own code, okay, first thing is bias because it is your own work. Am I right? Your work is always perfect. Correct? I cannot do mistake. I know well what I have understand and what I have done. So in that case, no matter how many times I test it, it's still going to work fine. Because it's very easy to find someone else's mistake than to find our own mistake. Correct? Yes. That's why we, the lecturer, we are very good in finding your mistakes. Okay, so if you see here, yes, it is possible for the programmers to test their own program, to test their own software, but the effectiveness level of the testing will not be there because of these issues. Because they know exactly how the correct logic work. They know exactly how they do the code. So when they are doing the testing, they only follow the right way to do the testing. So that is how the testing can be biased there. So the result might not be as effective as how when it will be tested by the tester or outsiders. Okay, so if you see, there is different independence level here to carry out the testing. So the first one is programmer by themselves, the software developers by themselves, because you cannot stop your programmers to do the testing on their own code because they are doing the code, they are going to test it first. Okay, then what will happen is that effectiveness level is not enough. Okay, it's not enough. So what will happen? We try to improve the effectiveness of the testing by letting someone else from the same team or same department to do the testing. So this is like pair programming. Have you heard pair programming? Two programmers sharing a work where one programmer will do the coding, one programmer will do the review, will do the testing, and will comment on the work. And this this role will be exchanged. So this is with the hope that someone else can see the mistake when you don't find your own mistake. Okay, but is it enough? No. Because when we sit from the same project, from the same development team, they have the same understanding. They know how the design of the code. they know how the requirement. So it is very difficult for them to think on the false part. They always go with the true part. Okay. Then the third level will be other departments. Other departments here means from the development department, it moved to the testing department. So it means the the system which has been developed by the software developers will be moved to the software testing department. So it means the software testers will be doing the testing. So if you see here, okay, of course for your assignment, you are going to be the person who prepare the test plan, who prepare the test case, and then you will execute your own test case. This is what will happen, okay? But maybe I was thinking to change it where within your own group, you are going to exchange to execute the test case. Okay, this is because the people who design the test case will not be the one execute the test case. For example, I design the test case. I will not be the one execute the test case, but I'm going to pass to some other software testers who has no idea about the requirement. This is because they can find the defect better. Got it? So they can do mistakes easily so that we can identify any hidden defect. Got it? So here the system will be moved from development department to the testing department with the hope the effectiveness will be much more higher, because software testing team will be outsiders where they don't have any much information about how the development has been done. Okay, but sometimes this can be not sufficient too. That's why we will be hired third-party tester. Have you heard that there are many software testing companies or freelance? They are outside there just waiting for us to call them to do the testing. They will come, they do the testing, they get the pay and they go. They don't care what happened to the system. They don't try to understand the system, okay? They just want to do the work according to the contract. They complete it, they get the pay, they go. So if you see, there is of course pro and cons when we are hiring the third-party tester, but the effectiveness level will be always the highest because there will be no bias happen. When you don't understand certain things, it means you will be exploring more. There is possibilities for you to see something else what the developer cannot see by themselves. Okay, so this will be the effectiveness level. So the lowest one will be the programmer who test their own program and move to another programmer and then move to the tester and move to the independent tester. It means the outsiders, the third party tester. Okay, so this is how the independence level of the software testing. Okay, so that's it for our chapter 1. Any question before I move to chapter 2?
No.
Any question before I move to chapter 2? All okay, yeah? Okay, so far so good. Okay, so chapter 2 is about a level of testing. Okay, so when we said we want to do testing is not one-time activity, correct? Do you agree? Based on your tutorial 1, there is I think 1 or 2 questions has been discussing about this, that throughout the software development life cycle we will conduct testing. Do you agree with that? Do you agree with that? Throughout the software development life cycle, we will conduct testing because we have different artifacts which we will produce and which we must test them. Okay, so here we are going to discuss about level of testing, what you already have discussed in your software engineering course before. Okay, from the smallest size to the bigger one. Okay, we start from the individual means what? The unit, the functionality, individual component, individual unit, and then how we are going to integrate them, become a module, integrate them, become the whole subsystem, and then integrate them, become the whole system. Okay, so every level here we will be involving with the testing. It's just that we are testing in a less complexity or more complexity. We are testing with only the source code, or is it a combined source code, or is it the UI? So we have different level of testing to see here. So we are trying to recall them back. Okay, so the first one is the unit inside the module. Okay, so when we say that you have one module, module A, inside the module you have multiple units or multiple functions, multiple operation. I don't know, there is different names. Okay, so when we set the unit testing here, where we are testing every single unit. Okay, every single function. Okay, I always like to use this CRUD. What is CRUD? Okay, create, retrieve, update, and delete. Okay, it's also same like add, view, edit, remove, same thing. Okay, but we go with this CRUD, create, to retrieve, update, and delete. So if you see, the combination of these four functionalities or four units become a module, because these four, they are not standalone units. Okay, except the first one, the create one. You need to create, am I right? So it's not depending on anything, but it will be checking if the record has been created or not. Okay, but when it comes to retrieve, when it comes to update, when it comes to delete, all these, they are based on the record which has been created. If the record is not being created, we cannot retrieve back, we cannot update, we cannot delete. So somehow they are working together. What you create, that's what you can see. That's what you can update. That's what you can delete. Okay, so each of these unit we actually need to develop, we need to test, and we need to make sure that they are functioning first before we can integrate them, become a module. So if you see, this is the smallest level, the less complex level. Okay, and at this stage it is more to the white box oriented. Why? Do we already have a complete system to do the black box testing? Not yet. So we are still at the coding development, doing the integration of the coding to make sure that this function can communicate with this function can take the data from this function. So those kind of things still part of the white box oriented, because we are going to use the compiler to do all this checking. Then from here it will move to black box later. Okay, so when we say that we want to integrate, okay, we want to do the testing, it is very important for us to know how we are going to integrate them and then to do the testing. So let's assume I have 4 different modules. Okay, inside these 4 different modules I have multiple units. Okay, and these units I have developed them, I have integrated them, I have module 1. Then the same thing goes, I have module 2, module 3, 4, 5, depends with your system. Okay, and maybe 2 of this module I need to integrate them as a subsystem. Then another 3 I have to integrate them as another subsystem. Or maybe all the 5 or 6 I need to integrate them as a complete system. Okay, so you guys are now working on your project. You suppose should know that a system means you are actually integrating all these little functions, all these modules to work together. That is how you get the whole complete. Not just go and start the code without knowing what you are doing. Okay, so especially when you are working in a pair for your software, for your project. 2 different people's work must be integrated. Okay, so when we want to do the integration, to do the testing, we need to know the right approach which we want to use. Okay, so we have 2 different approaches here, which is incremental approach and the non-incremental approach. Please do not get confused. Okay, incremental approach here means where we combine the next module to be tested with the previously tested modules. Okay, this is something same concept like incremental model. Have you heard about incremental model, part of the software process model? How the incremental model work? Are you completing the entire project one shot? No. How incremental model work? How you break them incremental by incremental, am I right? So normally we start with the main module, okay, and then we are going to develop, to test, to deploy out. And while the client using the main module, we will start with the second incremental, the supplement modules. Then after that, the same thing, we will do the development, we do the testing, we deploy out. So when we are deploying out here, are we deploying out as a separate? No, but you are going to combine the second incremental module with the main module to integrate them, and then you need to test them. And you need to make sure that now your client gets something more than what they have been used. So this will be continuously happen until we able to integrate the whole system. So here the same thing, when we say incremental approach, it means we have tested one module, and when we want to test the next module, we will combine them or we will integrate them with the previously tested module. Okay, later I will show you the figure. Okay, so that is incremental. So we are going to keep on combine, test until we will complete the whole system. The second approach here is non-incremental approach. So when we say non-incremental approach, it means there is no combination happening frequently. What happened is each of the module, let's assume you have 5 modules, each of these module will be tested individually or independently. Then I'm going to combine all these modules as a whole system and I test them second round. Correct? Clear? Incremental approach means every module which we want to test must be combined with the previously tested module until we completely integrate all of them as a whole system. Okay, but when we say non-incremental, it means each of these module will never meet other modules yet. They will be tested individually, independently. Then after we test all of them, we combine them as a whole system and we test them for the second round. Done. So how many times the combination happen in non-incremental? Only one time. It means we combine them as a whole system. Okay, let's see the figure. Okay, if you see here for the incremental approach, okay, it's actually the same figure. So for the incremental approach, okay, this is hierarchy of a system. Okay, we have three different levels where we have the A as a main, and then we have the second level which is having the B, C and D, and then we have the third which is E and F. Okay, so when we say incremental approach, okay, it means we are going to start from somewhere, either the top or at the lower place. Okay, so we are going to test. So based on the example given here, okay, we will test from the lower, where we start with E, we start with C, we start with F. It means I test E, I test C, I test F. Okay, after that what will happen is B is going to be combined with E, I need to test. And then D need to combine with F, I need to test. So it means I finish the lowest level and then I move to the higher level, and then all this which is the B, E, C and then D and E will be combined with the A when I want to test the A module. So it means I have combined them all and then I will test. So if you see, every time when a new module need to be tested, it must be combined with previously tested module according to the hierarchy. Got it? Clear? Okay. When we want to do this incremental approach, we have two different strategy which we can choose, which will be top-down strategy. It means we start from the top of the hierarchy and move to the lower level until the lowest level. We call this as a top-down strategy. So I have the main module and then I move to the second level and then I move to the third level until I finish all. So we always start from the initial module or the main module. So just now from the hierarchy, what was our main module? From the figure just now, what was our main module just now? No. I mean, what module was on the top? A. So it means we start from the top, which is the module A, and then move down. Okay. Got it? Top down, huh? Okay. The second strategy is bottom up. From the same hierarchy, we will start from the terminal modules. It means the lowest level modules of the hierarchy, the last one. Okay, and then we will move to the higher until we reach the main module. So it means based on the figure here, okay, when I say top to down, it means I start from the A and then I move to the B, C, D and then I move to E, F. This is top down. Okay, and when we say bottom up, it means I start from the bottom, which is the E, F or E, C, F, and then we move to the higher and then we reach until the main module. This is two strategy. So when we said incremental approach, we always have a choice of this strategy, either top-down strategy or bottom-up strategy, because we need to combine them. So we need to know where we are going to start so that we will combine them correctly. Okay, so when we say top-down strategy, it means when we already have whatever the main module needed. It means I have completed the top part. Then I can start from there. Got it? It means the development has been completed from the main part. So if we already have the main module, it means we can start to do the testing from the main, move to the lower level. So we can use the top-down strategy. So let's assume you are developing from the lower level. It means let's start with the input-output functionalities, all these things. Last one, we will do the main module. You know, there is some development like that, right? They leave the main module to be the last thing to done. So it means if we have completed from the lower level code, lower level or terminal modules, it means we start from the bottom up. So normally to choose this strategy is always depend on how we have completed our development. Do I need this approach, this strategy if the system is already integrated? No need. Okay, so that's why when we are doing a testing for a newly developing system, it is very important to know about this approach, this strategy. So if the development has completed, okay, let's assume when we want to do the integration, the development has completed 90%. So it means 10% is still missing there. It's not yet complete. Okay, so from what we have seen, they have completed all the terminal modules code. Those functions all has been done. So it means we can choose the bottom up. Because don't waste your time to be waiting for something which is still missing. We have the 90% which we can start ready. So the 10% leave it first. So let's assume if the same 90% is actually completed from the main module. The lower part is missing 10%. So it means we choose the top-down strategy. Got it? So this is for incremental approach. When it comes to non-incremental, okay, the same figure, the non-incremental here means, okay, each of these module, it means module A, B, C, D, E and F will be tested individually. And then once all these 6 modules has been tested individually, we combine them all together, become the whole system and test them second round. In this situation, do I need to worry about which strategy to use? In this situation, for the non-incremental, do I need to bother about which strategy to use, either top-down or bottom-up? No need. Because each of these module will be tested independently without depending or without combining with another module. So we will combine them only after we have completed all the individual module testing. Then we combine them as a whole system. We test them for the second round. So in that situation, for non-incremental approach, we don't need any strategies. Clear? Can understand the difference between non-incremental approach and incremental approach, and why incremental approach need the top-down or bottom-up strategy, and why non-incremental don't need that strategy? Can you understand? Okay. So, as part of the testing, as part of the integration to do the testing, okay, whenever we have missing, okay, like just now I say that the development has been completed 90%. It means the 10% there is still missing code, correct? It means development is still going on, not yet completed. So we have that 10% missing. Because of that 10% missing, I cannot wait longer. I still need to do the integration to do the testing first while waiting for the 10% to be completed. So in that situation, we will need to use dummy code. You should have heard that. What is dummy code? Because we want to replace the missing part of the code with the dummy code for temporary testing purpose. Okay, so when we set dummy code, we can replace them at different level, either at the higher level of the hierarchy or at the lower level of the hierarchy. Because remember just now, we say that we need to choose the strategy based on which part has been completed first. So to replace the missing part, we need the dummy code for testing purpose. So in that situation, we need to know either we are going to use driver or stop to replace this. Okay, so if you see driver and stop, they are the term being used for dummy code. It means when there is missing code happen, for us to do the integration, we need to replace with a dummy code. So this driver and stop is having different name here because of where we will replace them. Okay, so driver and stop used to replace the missing software and simulate the interface between the software component. So whenever we have any missing, whenever we need to test them, to integrate or to combine them to do the testing, we need to replace them with the dummy code. Okay, so if you see here, I have component A and I have component B. Okay, from the figure there. So let's assume component A is higher level, component B is lower level. So normally who call who? Who call who? Which component call which component? Huh? Component A will call the component B. Normally the one having the higher level in the hierarchy will be doing too much to call the component B. Okay, so here the same thing. Okay, so if you see here, there is two different situations. We will see when we need to use driver, when to use the stop. Okay, so if you see, the component A is to calculate the total marks. The component B to calculate marks for a particular subject. Which suppose should happen first? To calculate the total marks or to calculate the individual subject marks? Which one you know first? Individual. Am I right? So it means you will be having the individual marks for your 3 courses. Okay, and then when you have these individual marks, then only we can call these marks to do the calculation of the total marks. So that's why component B is at the lower place and then component A is at the higher place, because they need to have the data from this component B to be used for their calculation. Okay, so first scenario here. So let's assume we have completed our component B, but we have not completed our component A. So it means there is missing code happen on the component A. So for me to replace the missing part in the component A, which is at the higher level, this dummy code will be called as a driver. So I need a dummy code driver to call the component B for me to test the component B. Okay, got it? So let's assume the second situation where we have completed the component A. Imagine, we don't even have the individual marks, but we already have the code for total marks. What will happen now? We cannot still test them. So we need to do the dummy code for the component B. So now when we say to replace the missing part at component B, which is at the lower level, then this is known as a stop. Okay, so from the situation here, I think we have mentioned just now, the higher level will be calling the lower level. So here, driver will be needed to call the lower level code. We need to prepare the dummy code, which is driver, to call the component B. Okay, and when we say stop, it means we need to prepare the dummy code stop to be called by component A. To be called by component A. Clear? Can you understand? Driver will be calling component B. Stop will be called by component A. Because driver is at the high level to call. Stop is at the low level to be called by. Okay? Clear? Clear? So now, when we have completed main module, okay, which strategy we will use? When we have completed main module, which strategy we will use? Sorry? What is it? I heard something. Say. Say, it's okay. You say something, I heard. But I just want to confirm it. If it's correct what I heard or not. If we have, no, strategy first. If we have completed main module, it means we have done at the lower level. Which strategy we will go with? Where we have completed? We have completed at the top part or bottom part when I said main module? Top part. So it means which strategy to use? Top to down, because we will start from where we have completed. So it means I will use top down strategy. So in top down strategy, I will need driver or I will need stop. Stop, because we will be missing at the lower level. Correct? So when we need any code, we will be replacing as a stop. So let's assume on the opposite, if we have completed the bottom part of the hierarchy, which strategy to use? We will start from the bottom up. So when there is missing code happen on the up part, what we will need to replace them? We will need the driver. Okay? So if you see, when we are using incremental approach, we always have a choice of strategy. Either top down or bottom up. So in that situation, if we need to have a replacement of a missing code, we always have a choice. Either we need to prepare driver or stop. Because according to which strategy we choose, we need to replace them. So that's why I was asking just now, if it's top down, then it means the upper part is already completed. So we need to have the stop. Okay, so that the upper part can call the stop. Okay, and if we are choosing the bottom up strategy, it means we have completed the bottom part. They might be missing happen on the higher part. So it means we need the driver so that the driver can call the completed part to do the testing. So when we choose incremental approach, we always have these choices. Which strategy, and according to which strategy we need the driver or the stop. I use the keyword of or. It means I don't need both. Clear? But when we use non-incremental approach, what will happen? What will happen? Do we have any strategy to choose? No. We cannot start from top or bottom because each of these module will be tested individually. Correct? So in that situation, I will need driver or I will need stop. For non-incremental approach, when there is no choice of strategy, I will need driver or I will need stop when there is any missing code happen. Only driver. Okay, let's assume this figure. For non-incremental approach means what will happen? I test E, I test B, I test A, I test C, D, E. Everything will be individually. Correct? So, if you see here, when I test E, which module I need? I need B. And in that situation, what I will need to replace the missing of the B? Are you sure? Stop. B is at the higher level of E or lower level of E?
Higher.
Higher level. B is on the higher level of A. So when we are replacing a code at the higher level, it will be driver. So let's assume on the opposite way. I want to test module B. Okay, let's assume I want to test module B. And module B is actually need to be integrated with the E and also A. Correct? So when I'm testing B and I need a missing part from E, I need driver or I need stop?
Stop.
Huh?
Stop.
Stop. Okay, stop. Because E is lower level than B. But when I test B, I need the missing code from A, which is higher. I need driver or stop? Driver. So in this situation, for the non-incremental approach, I need driver or I need stop? Yes, you need both. You need driver and also you need stop. When I test E, when I test F, I need driver because there's nothing below that. But when I test B, when I test C, when I test D, what will happen? I need driver and also I need the stop. So compared to compared to incremental, non-incremental, we will need more WCOM. Because when we are testing each of these module individually, according to where is the missing part, we will need the driver and or the stop. Clear? Clear? Okay. So just to recall back, incremental approach, we have strategy to choose according to where we have completed we move from there. Okay, and what is the missing part? According to the level, we will need driver or we will need stop. It's always a choice. Only one needed. But when it comes to non-incremental approach, we don't have choice of strategy because we will test each of them individually. So when we are testing them individually, any missing part on the lower level, we will need stop. And any missing part at the higher level, we will need the driver. So driver will be calling other component. Stop will be called by higher level component. Clear? Okay, this one I'll come back. Okay. Clear? So far so good? Okay. What are the advantages and disadvantages of incremental and the non-incremental approach? Okay. Which approach is better? No worries. The answer is already given. We are going through the answer one by one to see what is the advantages and what is the disadvantages, and we will decide which one is a better approach. Okay, so the first one, like what I have mentioned just now, non-incremental, you will require more work because you need to prepare more dummy code because you will need the driver and also the stop. Okay, but when it comes to non-incremental approach, according to the strategy which we choose, we will need only driver or the stop. So it means non-incremental is having a disadvantage here, which is requiring more work compared to incremental. Can someone keeping the score? So 1-0. Okay. Incremental is 1, non-incremental is 0. Okay, on the second point, programming errors or any incorrect or any mismatch or any issues between modules can be detected earlier in the incremental approach because module will meet another module much more earlier before they come a complete system. Because when we say incremental approach, the next module will be combined with the previously tested module. So it means when we combine them early, we can detect the programming errors early. But what happened in the non-incremental approach? Since each of these module will be tested individually, independently, without seeing another module, only when we combine them as a whole system, then we are going to detect like thousands of programming errors. So, who is having the advantages here? Which one is better? To detect the programming errors earlier is better or later? Of course, earlier. So, it means the incremental approach can give us the advantages here. Okay, so 2-0. Correct? Okay. So, according to the second point, when we able to detect the programming errors earlier, how will be the debugging process? It will be much more easier. Am I right? Because the code complexity, the code which we are dealing, because line of code is always indicate the size of the software and how complex it can be. So when we able to detect the programming errors earlier, the debugging process will be easier, and the cost, the resources, the time, everything will be lower. So in incremental approach, the debugging process will be much more easier compared to non-incremental approach. So who is having the advantage here? Incremental approach. So 3-0. Are you keeping the score? Okay. Then the fourth one is the exposure of the testing. So if you see, every time the more combined in incremental approach will be tested again and again. So the exposure of the testing for the module will be more. Do you agree that the more we are testing, the better the module can be? The quality can be actually improved. So here, each of the module under the incremental approach can receive more exposure of the testing. Where in non-incremental, they will be tested one time as an individual module and then will be tested after combined as a whole system. So the testing exposure is lesser. So who is having the advantage here? Who is having the advantage here? Incremental approach. So 4-0. Okay. Then the fifth one is the machine time. So machine time here can be used for two different work. Machine time for the testing exposure and machine time for preparing the dummy code. There are two different. Okay, so the first one, machine time to execute the testing is actually lesser in non-incremental approach. Correct? Because we test individual module, we combine them as a whole system, then we test them. So here the machine time used for the test execution is lesser compared to incremental approach, because every time module being combined, it will be tested again and again. So the machine time which used for the test execution is actually more. So which one is better? Lesser or more? We always go for the lesser, am I right? So who is having the advantage here? Non-incremental. So what is the score? What is the score now? 4-1. 4-1. Okay. Let's see the machine time which is used for the preparation of dummy code. It means to prepare the driver and the stuff. So since we have discussed just now, for non-incremental, we need driver and stuff. Correct? We need both of them. So it means the machine time which will be needed to prepare the driver and stuff will be more in non-incremental approach. And because in incremental approach, we just need only one, either driver or the stuff. So it means the machine time which is needed for the preparation of the driver or the stuff is lesser. Can see the difference of how the machine time is being measured here. So machine time which is used for the preparation of driver stuff is actually lesser in incremental approach. So who is having the advantage here? Incremental approach. So 5-2. Okay. Machine time is calculated for two different work. So one is having the advantage for the non-incremental and one is for the incremental. And the last one is, since non-incremental, we test them individually. The module will be tested individually. It can support parallel testing. You know what is parallel testing, right? Because they don't depend on another module. So I can test this one, I can test this one, I can test this one at the same time. So that will never happen in incremental approach, because you need to wait for the module to be combined first, then only we can do the testing. So here non-incremental is having an advantage. So our score is 5-2. Okay, so let's see. In summary, based on the point 1 until point 4, the advantages go to the incremental approach, and the fifth one and the sixth one, the machine time for the preparation, for the execution and the parallel testing activity is actually advantageous for the non-incremental. Okay, but based on the current trend of the computing industry, the hardware cost is actually not really high compared to the cost on the resources. So in that situation, no matter how much we are using the machine time, it is not really a big disadvantage. So compared to that, since incremental approach has a biggest advantage, which is early detection of the programming error, and the debugging process will be easier, can actually save a lot of money. So the expenses which we can use on the time, on the resources, material resources, human resources, which is kind of very high now, it actually can be saved. So in that conclusion, okay, incremental approach will be always a better approach compared to the non-incremental approach, because the disadvantage of the incremental approach is not a big loss, because the advantage is actually more than that. Okay, got it? So the conclusion here is the incremental approach is better than the non-incremental approach. Okay, so that's it. We will stop until here. Please don't forget to mark your attendance. I'm not helping anyone to mark.